Welcome back to my channel. Generative AI is rapidly changing how we interact with technology. At the heart of this revolution are powerful models capable of creating new content. Among these models, encoder-only architectures are gaining prominence for their simplicity and effectiveness. These models, as their name suggests, rely solely on an encoder, challenging the traditional notion that decoders are essential for generating outputs. Encoder-only models are proving their mettle in various AI tasks, from text summarization to image generation, demonstrating their versatility and potential. Their rise in popularity stems from their ability to efficiently capture and represent complex data, paving the way for novel applications in artificial intelligence. This essay will delve into the world of encoder-only models, exploring their architecture, functionality, and significance in the realm of generative AI. We will unravel the reasons behind the absence of decoders and how these models manage to generate impressive outputs without them. By understanding encoder-only models, we gain valuable insights into the evolving landscape of AI and the potential these streamlined architectures hold for the future. Encoder-only models, true to their name, consist solely of an encoder. This encoder acts as the powerhouse of the model, responsible for processing and compressing input data into a condensed representation. This representation, often referred to as a latent space representation or embedding, encapsulates the essence of the input data. Imagine the encoder as a skilled artist tasked with sketching a portrait. Just as the artist captures the defining features of their subject, discarding extraneous details, the encoder extracts the most salient information from the input, encoding it into a compact form. This compressed representation, like a well-executed sketch, retains the crucial elements while discarding unnecessary noise. The encoder itself comprises multiple layers, each contributing to the process of data transformation. These layers work in unison, progressively extracting and refining features from the input data. The output of the final encoder layer is the coveted latent space representation, a distilled essence of the original input. This architectural simplicity, devoid of the complexities introduced by decoders, is one of the hallmarks of encoder-only models. It allows for efficient training and deployment, making them an attractive choice for various AI applications. Traditional generative models use an encoder to process input data and a decoder to generate outputs. Encoder-only models show decoders aren't always necessary. Encoders create meaningful representations that can be used directly. This simplifies architecture, reduces costs, and opens new AI possibilities. How encoders stand alone in output creation. The absence of a decoder might seem counterintuitive for a model tasked with generating outputs. How can a model solely focused on encoding data produce anything new? The answer lies in the versatility of the latent space representations generated by the encoder. These representations, far from being static, are dynamic and manipulable. They can be compared, clustered, or even arithmetically manipulated to generate novel outputs. For instance, in image generation, one can interpolate between the latent space representations of two images to create a seamless blend of their features. Think of it like baking a cake. The encoder in this case is like a recipe book that provides instructions for creating different cake batters. You don't need a separate decoder to turn the batter back into the recipe. Instead, you can use the batter directly to bake different types of cakes, depending on how you choose to combine and modify it. Similarly, encoder-only models can generate diverse outputs by manipulating and combining the information stored within the latent space representations. This approach allows for creative generation without relying on a separate decoder to translate back into the original data format. Contrasting approaches, encoder-only versus encoder-decoder architectures. Encoder-only models focus on extracting meaningful representations directly, while encoder-decoder models reconstruct the original input. Choose encoder-decoder for tasks like translation, and encoder-only for tasks like clustering. Where encoder-only models shine. Encoder-only models are proving their mettle in a variety of AI tasks, demonstrating their versatility and efficiency. Their ability to capture and manipulate latent space representations makes them particularly well-suited for tasks that don't require reconstructing the original input. One area where encoder-only models excel is anomaly detection. By training on a dataset of normal data, the model learns to represent typical patterns effectively. When presented with anomalous data, the encoder struggles to create a meaningful representation, signaling a deviation from the norm. Another area where encoder-only models shine is in similarity search and clustering. By comparing the latent space representations of different inputs, the model can identify items that share similar features or group them based on underlying patterns. This has applications in recommendation systems, image retrieval, and even drug discovery. Moreover, encoder-only models are gaining traction in creative domains like image and text generation. By manipulating latent space representations, these models can generate novel and diverse outputs, pushing the boundaries of AI creativity. The impact and future of encoder-only models in AI. Encoder-only models are changing the landscape of generative AI, offering a simplified yet powerful approach to data representation and manipulation. Their ability to extract meaningful representations without the need for reconstruction opens up new possibilities for various AI tasks, from anomaly detection to creative generation. As research in this area progresses, we can expect to see even more innovative applications of encoder-only models. Their efficiency and versatility make them an attractive choice for researchers and developers, seeking to leverage the power of AI for a wide range of real-world problems. The future of AI is likely to be shaped by models that can efficiently capture and utilize the essence of data. Encoder-only models, with their elegant architecture and impressive capabilities, are poised to play a pivotal role in this exciting journey.